gonna be, the magic bullet. I think it's still gonna be doing the work, but I hope it's gonna help you in some way, shape, or form. So I give you general steps there. Let's look over those first. So after I'm done going over this worksheet, I'm gonna group you up, and the goal today is to read a word problem and try to sketch it and label it properly. If you can do that, the solving part, I think, is going to be easier. Not necessarily easy, but easier if you know how to set it up properly. So here it is. In general. So unfortunately, this is not in your booklet, but you can staple it to the back if you want. There are some scenarios you will encounter. In order for a problem to be solvable, you need at least 3 pieces of information. There's one exception here. If you have 3 angles in a triangle, you cannot solve that triangle. AAA, right? You cannot solve. You can solve SSS, but the triple, like 3 A's, cannot be solved. Just so you know, you need at least one side. So I would always recommend sketch your interpretation, label the known measurements, right? Next, identify the unknown angles and or sides that you will need to calculate by assigning a variable to it. So kind of plan it out, and sometimes you can do this as you work along. Maybe it's like, right now I don't know what to solve for. I'm just going to start here. I'm going to call that side X, and then keep solving. I'm going to call this side Y, or that angle, I'm going to call that A or B or C or whatever. Thirdly, use what you already know, right? Sum of triangles is equal to 180. What? Watch this one here. Alternate interior angles. How's that going to come back, Mr. Dirksen? I don't get that part. It's coming back. You can use subtraction of angles. I'm going to show you that in a bit. You subtract 2 angles to get the one you really want. We can use supplementary and complementary angles, right, to determine other angles that might be useful. I would say all of this should be done before you even start solving, right? You try to populate it with as much information as you can, right? Fill in, use pencil for your original, and then as you move in, I would use a pen, right? These are the numbers that I'm adding based on what I have, okay? If the height or altitude is provided, I should have also mentioned depth, right? It's the same thing. You will be working with right triangles, so just keep that in mind. There will be a right triangle if you know the depth, right? The height of the triangle. Check if the information you transferred makes sense and is in the correct place. And now you can set up and solve, include units, round to 2 decimals, right? So this is what I would suggest. Obviously, you don't have to stick with that. It's flexible, right? It's fluid. You can come up with numbers as you go along, but maybe you need a bit of guidelines. So the 2 scenarios that involve an angle of depression, right? These are the most popular cases with angle of depression. So I hope you're not depressed when you see the diagrams, right? Oh my goodness, right? Don't worry about it. It's actually not that bad, okay? So where can you see angles of depression here? Remember, it's always with respect to a horizontal line. So imagine, I just give you a scenario. A ship is scanning, right, from the top. There's a radar, and it scans, for example, like there's a wreckage down here, maybe the Titanic, right? And it spots the front, and it spots the back of it, right? So there's a way we can figure out what the length is of that wreckage down there. And in this scenario, height is provided. Watch this. Height is provided. Check. This is angle of depression. Check. This is angle of depression. Check. So you have 3 pieces of information here. Here's the alternate interior. Are you ready for this? Do you see alternate interior angles? This is the ocean, like the surface of the water. and this is the bottom. In this particular scenario, these lines are parallel, right? So if this is 30, this is also going to be 30. If this is 45, that is also 45. Okay. So it's actually pretty cool, right? You can transfer what's outside into the triangle here. There's a big triangle, and there are two smaller right triangles as well. So keep that in mind when you work through these. I don't want to label it too much because you might think, oh, it's always going to be like this. It's always going to be like that. It may be that the question does not give you the height. It may be that the question says that the radar, the measurement, direct measurement to the front is 1500 meters. Like this here is 1500. I put a Z there because I didn't know what it was. Maybe the 1500 will belong there, and this will be just labeled height. That's something you're going to have to determine, right? So the scenarios are very flexible. So watch this. Everything has a letter Z. X is just from here to here. Maybe let's add that to clarify. That's X, and this is Y. Okay. So technically, if you find X and Y, you could add them up to get the total distance between these 2 points here. And so that's what I'm trying to do here, just to give you a scenario. So how would this read? Right, there's a ship, and it looks towards the back at an angle of depression of 30 degrees. Spots the front of the wreckage. Then the scanner also picks up the front of the wreckage at an angle of depression of 45 degrees, right? So this is the scenario that's depicted here. Then there is the angle, two angles of depressions here, right? You have your plane at an altitude. This is height, right? Height is provided, check. And you've got two angles. That's probably a good idea there to have that. We know that this is 30 here, and that, so let's give a scenario. The pilot spots, you know, maybe this is the start of the runway, and this is the end of the runway, right? And they are spotted at different angles of depressions, right? And so that's what's happening here. And maybe it says, the question says that the plane is flying at an altitude of 20,000 feet. How would I find this angle right here? That's the one. I wouldn't mind adding that to this. If I just wanted this, how would I find that, given that this is 45 and that's 30? Let's call this theta. I haven't used theta a lot, have we? Theta would be 45 minus 30. That's what I mean by subtraction of angles. Theta is 15 degrees. Okay. So you can actually, let's just leave it like that. We all know that that's theta. We just, this little sliver is, right, 45 minus 30 gives you that little sliver. Okay.
Please excuse the interruption, but at this time we'd like to invite any grade 9s who either didn't get your photo or would like to have retakes done. If you would head down to the theater now quietly. Thank you.
Do you see alternate interior angles here in this scenario? You should always be able to see them. These lines, how about we go back here, just say that, I'm going to use pink. Right? This line is parallel to that line. So is this one here. That imaginary horizontal line is parallel to the ground. So you should be able to see, if you follow this transversal here that has the 30 touching it, that 30 could come in here as well. Do you think it's going to be too messy if we do that? 30, right? No, Yeah, 30. And this 45 belongs to this whole thing here. So technically the 45 comes in down here, right? Because it follows this transversal here. So the 45 that touched this transversal gets transferred over here. So now you have, this angle and that angle. Could you possibly find this one here? What kind of angles do we have down here? It's a straight angle, right? So to get that, we would go 180 minus 45, which is 135 degrees. Okay. So as you transfer angles over, you're going to start seeing more, that appears, and you can fill in whatever you want and go from that point. And remember, there's a right triangle here. So if this is 90 and that's 45, this has to be 45 as well, right? Because the angles within this triangle add up to 180. So do the angles in this triangle here. And watch this. So does this big right triangle here. Okay, so it should all jive no matter where you check. It should all jive.
Sorry to interrupt again. Just to be clear, this is all grade 9 retake or photos taken, and it is in the cafeteria. Again, grade 9 heads to the cafeteria if you retake or turn your photo again.
Okay, let's do this as well. I think it's good that we do this. Right? 45. We just write down alternate interior angles are congruent. And so you can populate a lot of things. You can just add numbers just like that. Just a quick, you're not doing a big, setup or anything. You just quickly filling it in. Okay. Let's go to these are, to be honest, these are the more challenging ones. The angle depressions are the ones that sometimes get students stuck. The backside, we have angles of elevation scenarios. So that's when you're on the ground looking up. So this would be your angle of elevation, right? They may not always call it angle of elevation. They may say the angle between the ground and the line of sight looking up. It's the same thing. So here we have, right, two angles and a side. You should see, forget about the height sometimes. Sometimes you just need to forget about it. You should see this pair here, which is a sine law scenario, right? If you have a pair, then maybe use this angle not to solve h, but to solve y. Because if you're comparing this angle over here across the triangle with this side, you need to do the same thing with this angle and that side. You can't say, hey, this is a pair, and I'm just going to go 43 over h. Not working, because the only way that would work is if you went with this 90 and you make your pair here and then use sine of 43 and h, then it would work to find h just there. But you can't go across the whole triangle here and then make another pair that just goes half of the triangle. You know what I mean? It's not half of the triangle, it's part of the triangle. So you got to be very careful that you don't mix up your triangles. Okay, so you have the hot air balloon. We could figure out how high above the ground it is. It could be that a person is standing here looking up at it, and another person is standing here looking up at it, and we, in this case, only know the direct distance from that second person to the hot air balloon, and then we just start solving, and maybe the question is going to ask you, how far apart are the people standing, right? What's the distance between the two? Maybe it's going to ask you, what's the direct distance from the first person to the hot air balloon? Maybe it's going to ask you, how high above the ground is the hot air balloon? I cannot tell you it's always going to be the same, okay? Next, we have this one we did yesterday. We had a tower and then two guy wires. You remember what that is, I hope, right? Supporting that. And it could be saying that the guy wires are anchored on the ground. They're 35 yards apart. Figure out the length of each wire and then figure out the height. All of those things you can do once you have the correct diagram, okay? So keep that in mind. These ones you should have seen this one in Intro to Applied and Pre-Cal. You should have seen something like this. And I know because I teach it every other year or so. And so you need to just be careful when you set this up, right? So in this case, there could be someone standing here and the angle of elevation maybe to the bottom of a billboard is 20 degrees of angle of elevation, and then to the top of the billboard, right, it's a 50-degree angle of elevation. So you set it up like that, and maybe the direct distance between the bottom part of that billboard is 7.3 meters. That's all we know, but we've got two angles on one side. We're in business, okay? You could figure out, right? I hope you know that 50 minus 20 gives you that 30 there. So that's for some reason students miss that. Okay, so to figure out this little sliver, let's call that theta. Okay. Theta is simply, and I use numbers that are easy to compute because I just want to make the point, right, that you should subtract to figure out that piece there. Let's talk about this one. How could this be a scenario? A classic one is someone is standing here looking up at a tree, top of the tree, or a cliff, walks another 35 yards closer to that cliff, looks up again. Now it's 100, an angle of elevation of 130. Right? That doesn't make sense. That's not 130. That's not an obtuse angle, would you agree? 130, this does not look like an obtuse angle. So let's change that to 30. My bad. See, that's why shouldn't have handed it out yet, but I think I needed it out for you to be able to use it already. So if this is 30, what's this one going to be here? I hope you see it. That's a straight angle there. So this will be, let's call that theta. Theta is going to be 180 minus 30. Theta is 150. Straight angle. So because we've done geometry, not to like we just did that, I would expect you to notice that. I would expect you to be like, oh, I'm stuck. Oh yeah, bring one in. Now you have two angles inside that triangle on one side. Angle, side, angle. You can easily find this sliver up here within this triangle. And then you have a pair. The 35 yards will pair up with this angle here. Okay, so that's something that would be found by using the sum of triangle. So I have some page numbers that I want you to try, and maybe I'll ask you to write them down on this piece of paper. I have them selected. They're kind of scattered in this booklet. So here we go. Write them down so that when I group you up, you know which ones to do. And what I'm going to do is I won't get every group to do every single one, okay? Because we're not going to have enough time for that. So let's say that group 1 will do 39, group 2, group 3, group 4, 5, 6. Watch this. I'm going to go 7, So 4 and 7 are going to do the same. And then 5 and 8, groups 5 and 8 will also do page 51. So groups 1, 2, 3, 4, 5, 6, 7, 8. Like that. And remember, so have this written down so you know those are the ones I'm going to try down. Okay. I wanna emphasize rigor. Rigor is you sitting down and working on your own. Okay. You need to figure that out. So here we had this hot air balloon, and we had two different angles of depressions. We were given the altitude, so aside two angles, you're in business. Okay, with these questions. So sketch a scenario, include all labels and measurements. Before I continue, I'm going to kind of follow my steps. Let's figure out what else we can fill in. Let's do that right now. We could bring in this 27. Watch carefully, guys. It touches this transversal. So I'm going to follow that and put 27 in here. Populate it. Then I know the 34 touches is with respect to the horizontal, sorry, and it touches this transversal. So I'm going to follow it, and I'm going to put 34 in here. That's simply by observation. Okay. You could now find this one here. Okay. I'm going to use a color. I like highlighters, as you can tell. In high school, you wouldn't even have seen a highlighter in my backpack, right? But I've changed since. So if this is 34, this is 146. 146. Okay, maybe I will say that for these two, I use alternate interior angles are congruent. I couldn't find the congruent symbol, so the one on your handout has just three lines as the equal sign. So boom, 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 all that is done. What else can you find? We're not done yet. Like it's a ripple effect. Okay, technically you could find this one here. There are a bunch of ways you can do that. We can use sum of triangle, right? We could use the fact that this is 34. So this must be 90 at this corner here. So you could just go 90 minus 34 to get that. It's up to you. So what is that? 6 to get to 40, so 56. Okay.
Quarterfinals of the league championship. The boys play PMCI at GFCI this Monday at 7 p.m. I recommend it or parking. And also at this time, if grade 10 students who would like retakes or did not get their photos taken the first time around, if you would please head down to the cafeteria now. Thank
you. Okay, 34 minus 27 is 7, right? 7 is that sliver. I'm going to use a highlighter for that. If you missed it, there's still a triangle here, right? So you could go 180 minus 146 minus 27, still 7, right? So regardless if you use sum of triangle or if you just subtract these two, you should still get 7. So here you go. Seven squared? No, I don't think so. 7 degrees, okay? So lots of information that can be added simply by using what you know about angles. That's why I always do angles before triangles. Okay, that unit, I always teach it before this one. That way you're prepared for it. All right, let's start solving now. This is when I start solving. Calculate the direct distance between Amanda and the Forks. So we want HF. Oh, sorry, we want Amanda and Fork. Sorry, I don't know why I went HF. Um, my letters are causing me issues here. You see that? Where's Amanda? She's over here. This is the artist Reed building. So again, be careful. Okay, my bad. It's actually asking for this distance here. Let's call that something. I'm going to call that X. So once you've identified it, it's easier to solve, right? Like, okay, that's what I'm targeting. So how would I do that? Let's see. I have a pair here and a pair. I can easily use the 90 to figure that one out. So let's go and do that. So for B, I'm going to use sine of 34 over 2,500 feet. And that's equal to sine of 90 over x. So this would be 2,500 times sine of 90. Do you remember what sine of 90 is? It's just 1. Comes in handy in grade 12 as we do the sine wave. Okay. This is, I should have the key in front of me, but I don't. So here we go, 2,500 divided by sine of 34. That's 44, 70, 73 feet. And that was so easy once you populated everything. It's not so easy when you don't, if you don't do that, it's harder to see, in my opinion. Okay. C, determine the distance between these two, the two spots that are being spotted. Why don't we call that Y? Okay. It's hard to see, but you should be able to conclude that this side is across this angle. So within this obtuse triangle here, you have a pair there, and then 7 will be across Y. Right? You see that? It's hard. I wish I could like zoom in or something, but sine of 27. You know what? Because these are, I don't give you a ton of examples, so I'm just gonna. Right, 27 is here. The 146 is here. 7 is there. This is now 44. I like on the whiteboards, you do that. You write down the number you solved, right? Like this number here, boom, it's there now. And this is Y here. Okay, let me zoom into that. So sine of 27 over 447073 feet. That's equal to sine of 7 over Y. You are expecting a very, like compared to the 4,000 side, you're supposed to have a really small distance, right? Because 7 is such a small angle. So we're going to go 4470, 73 times sine of 7 divided by sine of 27. And I need to calculate this. And I like how a lot of you did it very differently compared to how I would have approached it. And I have no problems with that. So that's how far apart the two sites are. Okay? And voila, right? But it all started with a good diagram. It all started with populating your diagram, and then you go from there. You got to be very careful that you make it legible, right? You got to make sure you label it. Don't just squish everything in. Maybe you have to make a new diagram. Who knows? Okay, so I'm going to say for homework, I will basically give you all the pages that I assigned today for the whiteboard activity. So I said 39, 47, 48, 49, 51, and 53. Oh, I forgot about 38. 38 is right next door. Sorry about that. Page 38. Okay. I will post the answer keys to all of them. It would probably have questions that are in between. Some questions are in between and you wonder why did you leave them blank. For now, let's just leave them because I always add more than what I need. I always do that. And so those questions, you might think, wow, that's a lot. What I would say is at least come up with a decent diagram and solve maybe half of them, right? Solve half of them, do diagram for all of them. Of course, I'm biased, I would say do all of them, but you know where you're at, right? So you need to at least put in some time. That's what I would say. What else do I want? Let me just